Chapter 7 review. This is Mr. Saari. All right. For numbers 1 through 4, we need to solve the following systems using substitution or elimination. And we're not using the matrix function on your calculator for this part of the review. Okay. So, here we go. So I see this one. I'm going to solve this one with substitution. We can use elimination, of course. I'm going to solve the rest of them with elimination. But I'm going to use substitution for this one, just for those that would like to see that kind of method. All right, so substitution involves isolating either x or y and substituting that value or that expression into the other equation. I'm going to start by adding y to each side of my equation. Let's make this thinner. All right. All right, so I've got x plus y. So I have x equals y plus 13, or 13 plus y. So I can take this y plus 13 and substitute in for this x, because I know it's equal to x. So I have 4 times y plus 13 plus 2y equals 10. Distributing this 4y into y plus 13, you get 4y plus 52 plus 2y equals 10. Combine like terms with 4y and 2y, we get 6y plus 52 equals 10. Subtract 52. 6y equals negative 42. And now I divide by 6, and I get y equals negative 7. So y equals negative 7. And then to simply solve for x, all I have to do is plug it back into whichever of my equations makes sense. So I'm going to plug it into the second one. X minus negative 7 equals 13. So it's x plus 7 equals 13. Subtract 7 from each side, we get x equals 6. So x equals 6. So you can either leave your answer like that, or write it as this ordered pair, 6 comma negative 7. Either one of those is a perfectly acceptable answer. All right, that's number 1. All right, 2 and beyond, I'm going to be using elimination. So let's change colors. All right, elimination. So notice that the y's are already the same here. Y's are already the same, but they're not opposite signs. So I'm just going to multiply this whole equation by negative 1. Multiply this entire equation by negative 1, and rewriting it. So I've got x minus 2y equals negative 21. So just reversed all my signs, essentially. I'm going to rewrite this one, 7x plus 2y equals negative 19. Now we can add these, and our y's will cancel out. So I've got 7x plus x is 8x equals negative 40. So solving for x, we divide by 8. X equals negative 5. X equals negative 5. And now we can solve for y by substituting back into one of our original equations, kind of like this second one. So I've got negative 5 plus 2y equals 21. So it's 5 plus 2y equals 21. Subtract 5 from each side of the equation. I get 2y equals 16. Divided by 2, we get y equals 8. So we've got x equals negative 5 and y equals 8, which we can write as the ordered pair, negative 5, comma 8. Again, if you left it as x equals negative 5 and y equals 8, that'd be fine. Or you can express your answer as this ordered pair. All right, so here with this next one for number 3. So we have negative 8x minus 10y equals negative 24, and 6x plus 5y equals 2. So we're looking for an easy way to cancel out a variable using elimination. And I see if we double 5, we'll have positive 10, which will then reduce, which then when we combine like terms with the negative 10, we'll eliminate. We'll go to 0. So we're going to take this whole equation, and we're going to multiply it by 2. Multiply this entire equation by 2 right here. So I rewrite it as 12x plus 10y equals 4. Again, notice I multiplied each one of these by 2. All right, I'm just going to rewrite this top equation that I didn't touch. Negative x minus 10y equals 24. And now I just add the left sides and add the right sides. So negative 8x plus 12x is 4x. And negative 10y plus 10y is 0. So we don't have to write a y term. 24 plus 4 is 28. Divide by 4, and get x equals 7. So that's the whole point of elimination. Eliminate one of your variables, then it becomes very simple to solve for the other one. So x equals 7. I'm going to substitute back into one of my original equations, either this top one or this bottom one, with my x equals 7 and then solve for y. So I'm doing this bottom one. I've got 6 times 7 plus 5y equals 2. So 42 plus 5y equals 2. Subtract 42 from each side. 5y equals 2 minus 42, or negative 40. Divide by 5, and we get y equals negative 8. So 7 and negative 8 are our two solutions, which we can express as an ordered pair, 7 comma negative 8. And that's our final answer. All right, number 4. All right, so notice how this is in row echelon form. If we're using substitution, we can use what's called back substitution. So notice how we have z equals a number already. So I can take this 2 and substitute in for that z to help me solve for y. So I've got y plus 6 times 2 equals negative 1. So y plus 12 equals negative 1. Subtract 12. Y equals negative 13. So I got y equals negative 13. I got z equals 2. Now I just got to substitute both of those in to this top equation, y and z, to then have an equation with just x in it. So x minus 2 times negative 13, that's y, plus 2, which is z, equals 4. So I got x minus 2 times negative 13 is plus 26, plus 2 equals 4. So x plus 28 equals 4. Subtract 28, and we get x equals negative 24. So you can leave your answer as x equals, y equals, and z equals, or you can write it as this ordered pair, negative 24, negative 13, 2. Notice how I put it in that x, y, z form. And that is our final answer. All right, solve the following matrix using Gaussian elimination. So, Gaussian elimination, what is this? Well, what it actually is, it's using elimination to create a problem that looks like this, that we can then use back substitution to solve. So we want basically an xyz equation, a yz equation, and just a z equals equation. So essentially what I want to have here is I want to create an equation with just y and z in it. So I want to cancel out my x's. Because notice how I have 3 different equations that I can use for my x, y, z equation. So x plus y, something x plus something y plus something z equals something. We have 3 different versions of those. So we're good for that. That one's good. Now we need, let's change to another color. All right, now we need just a something y plus something z equation. All right, and how I can do that is by eliminating the x's. So I see a couple different ways I can eliminate x's, starting by just adding equation 1 here and equation 3. So I'm going to do equation 1 plus equation 3. Because notice how I have negative x and positive x. I add those together, and that'll cancel out my x's. I'm just going to copy them first. So I've got negative x minus 5y minus 5z equals 2. So that's my first equation. Now equation 3 is x plus 5y minus z, which equals negative 20. Okay. So I'm already seeing something here. So add these together, and the x's cancel and the y's cancel. That doesn't normally happen. So let's see what happens with this. So I got negative 6z equals negative 18. So now I can just go ahead and solve. I get z equals 3. So I was anticipating getting my yz equation, but I really just have my z equation. So I got z equals 3. So I got my z equation. Now I need two other ways that I can cancel out x's. So what I'm going to do is I'm going to cancel out my x's by combining equations 1 and 2, and then equations 2 and 3. So let's do that. So here's equation 2. So I'm going to do equation 1 times 4 to get this into negative 4. And I'm going to add equation 2. So my plan, I'm doing equation 1 times 4. And then I'm going to add equation 2 to that. All right, so first we need to do equation 1 times 4. So equation 1 times 4 is negative 4x minus 20y minus 20z equals 8. That's equation 1 times 4. I'm just going to copy equation 2. So 4x minus 5y plus 4z equals 19. All right, so I add these together, and I get negative 25y minus 16z equals 27. All right, so there's my one blue equation that I can use for that. So I have one of them, and now I can use back substitution to solve. Because I have this one, I have z equals 3, I've got this one, I've got the red one, and I'm good to go. Now, we lucked out to get this z equation with just one step. Oftentimes, what you'll have to do, if there's no way to get a z equals equation, just a z equals some number equation by adding these equations directly, what you'll have to do is make a second y and z equation using a different combination than what I already used. And then I'll use elimination with those two to get a z equation. So that's sometimes what you have to do. We didn't have to do that this time, though. All right, so I've got my equations. For my red equation, I can use whichever of the three I want up here. Let's go back to blue. All right, so for my red equation, I can use whichever of these three that I want. I kind of like the third one. So I'm going to do x plus 5y minus z equals negative 20. Then for my green equation, I have that down here. I've got negative 25y minus 16z equals 27. And then for my z equation, I've got z equals 3. So I already got z equals 3. So I'm going to take this, plug it into this one right here. And I get negative 25y minus 48 equals 27. So negative 25y plus 48 at each side equals 75. Divide by negative 25. And I get y equals negative 3. So I got y equals negative 3, z equals positive 3. And now I just plug these into my y and z of any one of those three equations, but I chose this one. So x plus 5 times negative 3 minus z, which is 3, equals negative 20. X minus 15 minus 3 equals negative 20. X minus 18 equals negative 20. Add 18 to each side. I get x equals negative 2. So that's my equation, or that's my solution. Negative 2, negative 3, 3. And I'm going to write that as an ordered pair. Negative 2, negative 3, 3. Just like that. And that's my final answer. So that is my final answer. Negative 2, negative 3, 3 for x, y, and z. All right. Next, we're finding determinants of matrices. We're finding determinant of a matrix. So remember, this is based on, it's similar, just but a little more complex than a determinant of a 2 by 2 matrix. Remember, if this were matrix A, what we're doing is finding this symbol, the determinant of it, okay? And the first step to doing that is, for a 3 by 3 using the lattice method, is copying these first two columns to make a fourth and fifth column. So we got 1, -3, -6, and then 1, -2, 4. All right, and we make three downward sloping groupings that I always do in red. So 3 downward sloping groups. And what we're going to do is find the product of the numbers in each oval or in each circle. And we're going to add all these. So we're going to do 1 times -2 times 4. That's the first thing we're going to do. So that's -8. And we're going to add the next one, 1 times 5 times -6. That's just -30. Let's say plus -30. Say add again, the last one, -2 times -3 times 4. So that's going to be +6 times 4, which is 24. Plus 24. So those are the sums of the positive ones. And then I usually change to a green color. And then we make 3 upward sloping groupings. And for each of these, it's the same thing, but we're going to subtract each one. So we're going to say minus, -6 times -2 times -2. That's going to be minus, it's positive 12 times -2, so minus -24, which we know will turn into positive 24. Minus again, 4 times 5 times 1. So that's going to be minus 20, positive 20. And then the last one, minus 4 times -3 times 1. So that's going to be minus -12. All right, so we know this will turn into, so changing colors here to be clear about what's happening. All right, so this turns into a positive. So this turns into plus 24 and plus 12, because minus and negatives. So we can combine like terms here. So we got -38. Basically, we just combine like terms with all these. These 3 red ones turn into -14. These other ones are positive 36 minus 20 is positive 16. So I got -14 plus 16, which is 2. And that is our final answer for the determinant of that 3 by 3 matrix. All right. So we're simplifying. If it's not possible, we write undefined. So first of all, how do we determine if it's not possible? Well, what we do for a multiplication problem is we write the rows by columns for each one. And the numbers in the middle have to be the same for it to be possible. So those numbers have to be the same. So let's write it down here. So this is a 2 rows by 2 columns. You got another 2 rows by 2 columns. So those numbers are the same. So this one is possible. And the way we tell what our solution matrix is we look at the outside numbers. So we know it's going to be a 2 by 2 matrix as our solution. So I'm going to make it 2 by 2 to plan this out. All right, so there's 1, 2, so the 2 rows by 2 columns. All right, so first, for this one right here, in our first row and our first column, we take our row 1 of the first matrix and multiply by column 1 of the second matrix. So I have 2 times 4 plus -1 times -3. So that's what the result is. I'm just going to write the answer out to the side over here. So 2 times 4 is 8, plus +3, so that's 11. So I have 11 for my first spot. All right, second one. We want row 2 times column 1, so we take row 2 and multiply it by column 1 here. So I got -6 times 4 plus 1 times -3. So -24 plus -3 is -27. All right. This third one, I take row 1 and multiply by column 2. So row 1 by column 2 here. So I take 2 times 4, and I add that to -1 times -5. That's 8 plus 5, which is 13. And then for this last one, I take row 2 by column 2, so row 2 here by column 2 here, so -6 times 4 plus 1 times -5. So -24 plus -5, which is -29. So that is the multiplication of those two matrices. All right, number 8. Adding two matrices. We can do this because we simply add the corresponding cells of the matrix. So we know this first one's going to be -2 plus 4, which is -6. -3 plus 6, which is 3. -6 plus 0, which is -6. And 2 plus -3, which is -1. So that is the solution to number 8. All right, some more matrix operations. Notice we're just tricking it up here by adding in some other operations mixed in. So I've got -2 times this entire matrix, which I have to do first, then I'll add it to this other matrix. So I'm just going to rewrite this, what this new matrix will be after I multiply -2 into it. So I've got 6, 0, 10, -10, 10, 12. I'm going to add that to this other matrix, which hasn't changed. 4, 6, -1, 3, -3, 2. Add the corresponding parts. So we've got 6 plus 4 is 10. 0 plus 6 is 6. Got 10 plus -1 is 9. -10 plus 3 is -7. Then 10 plus -3 is +7. And 12 plus 2 is 14. So that is our answer to this number 9 here. All right, same thing goes here, but I'm subtracting. So what I'm going to do, I'm going to distribute this negative into all of these, and then just think of it as addition. So this becomes positive, 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 negative, positive, positive, negative, positive, positive. So now we can change it into plus rather than minus after I distribute that negative. All right, so we got -4 plus 6, which is 2. We've got -5 plus 1, which is -4. We've got 5 plus 6, which is 11. We've got 1 plus -6, which is -5. 6 plus 3, which is 9. 3 plus 2, which is 5. -2 plus -4, which is -6. 2 plus 1, which is 3. And 1 plus 3, which is 4. So that is the result of the subtraction of those two. Okay, so now we've got multiplication here. This is a 4 by 2 matrix times a 2 by 2. And since these two numbers are the same, this is possible. And we know we're going to need a 4 by 2 output. So we need 4 rows by 2 columns. All right, I'm going to spread out these columns a little bit so we can have some room to write, plan it out. All right, so row 1 times column 1, so 3 times 2, 3 and 2 times 0 and 2. So I've got 3 times 0 plus 2 times 2. All right, which I will write down here. That is going to be 4. Next one, I've got 2 times 1 times 0 and 2, so 2 times 0 plus 1 times 2, it's going to be 2. I've got 3 and 4 times 0 and 2, so 3 times 0 plus 4 times 2, so that's 8. And then finally negative 1 times 0 plus negative 1 times 2, it's just going to be negative 2. All right, that's my first column. All right, second column, I take my first row, multiply by column 2 now. So I've got 3 times 0 plus 2 times negative 6, that's negative 12. And I've got second row, second column, 2 times 0 plus 1 times negative 6. That is going to be negative 6. Third one, 3 times 0 plus 4 times negative 6. So 0 plus negative 24, negative 24. And finally, negative 1 times 0 plus negative 1 times negative 6 is 6. So that's my solution matrix to this number 11 here. All right. This one is scalar multiplication, where I just simply multiply this negative 4 into every term. So 2 by 2, we've got negative 20, got negative 4, negative 24, and 0. So that's the solution to number 12. All right, finding the inverses of matrices, finding the inverse. So if you're given a matrix A, here's the formula first. So if matrix A is A, B, C, D, then A inverse, the inverse of A, is 1 over the determinant of A times a rearranged version of matrix A, where you swap A and D, so it goes D and A, and then you negate the other two terms, negative B and negative C. So that's how you find the inverse of the matrix. So A inverse equals, well, we need to know the determinant. So let's find the determinant. Determinant of A. So I'm going to do, remember, determinant is 11 times negative 1 minus 2 times negative 5. We do that cross product. 11 times negative 1 minus 2 times negative 5. It's negative 11 plus 10, so that's negative 1. It's a nice clean number for us to use, which is nice. So I got 1 over negative 1 times the rearranged version of matrix A. So I swap those two. So I got negative 1 and 11, swapping those two. And I got to negate those two. So I got negative 2 and positive 5. So A inverse is just 1 over negative 1 times this. Well, 1 over negative 1 is just negative 1. So all I have to do is reverse all these signs. So I have 1, negative 5, 2, and negative 11. And that is my solution to number 13. All right, 14. So we're finding the inverse of this one now. So same formula applies. So we got to find, so A inverse is going to equal to 1 over the determinant of A times the rearranged version. We swap those two, so it's 6 and 3. and then negate those two, so positive 4 and positive 2. So that's what we're going to find. So we need to find the determinant, and we'll then multiply it into this matrix. So determinant of A, let's find it. We do 3 times 6, which is 18, minus negative 4 times negative 2. So we're at 18 minus 8, which is 10. So I've got 1 over 10 times this matrix, 6, 2, 4, 3. And all I do is multiply this 1/10 in there. So you can either leave it as a fraction or an exact decimal. I'll do both. So I've got 6/10, 4/10, 2/10, and 3/10, which you can reduce, or you can write it as 0.6, 0.4, 0.2, 0.3. And that is our solution to the inverse of that. Okay, so now we can use the matrix function on our calculator during this portion of the review. So we are finding the inverse of this matrix on our calculator. So, nice part about this is that you can just plug it into the calculator and then hit the inverse button on the calculator. So here we go. So we go to matrix. Whoops, not what I wanted. So second matrix. Go to edit. And I know I want to create a 3 by 3. So 3 by 3. So let's do it. 1, 1, negative 2. So 3 by 3. It starts as 1, 1, negative 2. It goes negative 3, negative 2, 5. Negative 3, negative 2, 5. And then it finishes up with negative 6, 4, 4. Negative 6, 4, 4. And we name this thing matrix A, because that's the one we want to use. So to find the inverse of matrix A, we just go to matrix menu under names, click enter, that brings it down, and that means we want the inverse, this negative to the 1 button, negative first power. So there is our inverse right there. Screenshotting that in. Let's insert this value in here. And there is our inverse. So that's the inverse of that given matrix. Okay. Now, for the following two systems, for 14 and 15, we are solving them using a matrix equation and our calculator, and we make sure that we write out the matrix equation to get full credit. Okay. So, here we go. All right, so x over 2 plus y over 8 equals 4, and then x over 3 minus y over 2 equals negative 2. Now this is a fancy equation we can rewrite as, remember, x over 2 is the same thing as 1/2 x. So we say 1/2 x plus 1/8 y equals 4, and then 1/3 x minus 1/2 y equals negative 2. So that makes it easier to write out the matrix equation because we have our coefficient matrix. It's 1/2, 1/8, 1/3, and negative 1/2. So that's our coefficient matrix. And we know it's multiplied by the variable matrix equals the constant matrix for negative 2, which are brought down from right here. So that's the matrix. And remember, the matrix operation that we're actually doing here is if we were to rename these matrices, call this one matrix A, and this one matrix X for the variable matrix, equals matrix C, or whatever for constants, then the matrix operation we actually have to perform is we got to get rid of this A. Well, to get rid of an A, that's just a stray mark, we multiply it by its inverse. And that's what we have to do on both sides of the equation. So this will turn into, this right here cancels out, turning into an identity matrix. And that's the reason why we're doing this, because this gets our variable matrix by itself, and we're going to do A inverse times C. So all we have to do to solve this is plug in this 2 by 2 for A, this 2 by 1 for C, and then perform the calculation on our calculator, A inverse times C. And that'll give us a 2 by 1 matrix that represents XY. Let's go ahead and write this out so we're ready to go. So XY equals, all right, so let's make our matrices in our calculator. So we got 1/2, 1/8. So matrix, I'm going to make it in B and make it a 2 by 2. So 2 by 2. And I know my matrices were 1/2, 1/8, 1/3, negative 1/2. Okay. So 1/2, 1/8, 1/3, and negative 1/2. Okay, so there's our matrix. So that's the coefficient matrix. So I put it in B. Now we need our constant matrix, the 4, negative 2. So I'm going to put that in matrix D. So 4, negative 2, second matrix. We can put it in C since I don't have a C yet. So 2 by 1, and it was 4 and negative 2. All right. So now we are going to perform the calculation of the inverse of our coefficient matrix times the constant matrix. So inverse of the matrix that I put in as B. So I have second matrix. I want B inverse. So I hit the B and then I hit inverse. And then I have second matrix again. And I want to do times this matrix C, which is our constant. And I get 6, 8. So 6, 8 is our solution. So we can say x equals 6 and y equals 8. Or we can say 6, 8 as an ordered pair for our solution. Either one of those is a good way to express our solution. Okay, 15. Okay, so it's the same thing again here as what we just did in 14, but we got a 3 by 3 coefficient matrix, and then a 3 by 1 variable and 3 by 1 constant. So here we go. Let's change colors again. All right, so here we go. Coefficients, -1, -5, -5. Got 4, -5, and 4. I got 1, 5, and -1. Okay, and I've got x, y, z. There's my variable matrix, equals my constant matrix, 2, 19, -20. So there we go. There's our matrix setup. Again, if we called this matrix A, this matrix X, and this matrix C, the operation we have to perform on our calculator is multiplying by A inverse on each side, because that is what will cancel this out, make an identity matrix, and leave us with an operation we can perform to solve for our variable matrix. So we've got to plug in matrix A and matrix C. So let's plug them in slowly but surely. So second matrix, I'm going to use E and F down here just because we don't get confused. So matrix E, I'm going to make my coefficient matrix. It's 3 by 3. And we can look at it. Okay, we look back at it. So we can plug it in now. So we want it to be -1, -5, -5. and then 4, negative 5, 4, and then 1, 5, negative 1. So there's our coefficient matrix. And now we go to second matrix again, and we'll edit F. That'll be our constant matrix. We want it to be a 3 by 1. And we know it's going to be 2, 19, and negative 20. Those are just the constants, what each equation was equal to in my system. All right, looking back at this, I have to do the inverse of the coefficient times the constant to solve for my variable matrix. So inverse of my coefficient matrix, which was second matrix. My coefficient matrix was E. I want the inverse of that, and then I'm going to multiply it by F, my constant matrix. So there's my solution, negative 2, negative 3, 3. So my x, y, z equals negative 2, negative 3, 3, which we can write as negative 2, comma, negative 3, comma, 3 as an ordered pair if we would like. And there we go. That is solving matrix equations with your calculator. Make sure you set up this part to get full credit. All right, now I've got some word problems.